Let us now describe the formation of stationary waves in a pipe that is closed at one end and open on the other end, or we call these closed pipe systems. Now, the boundary conditions for these are slightly more complicated. You must have a node on the closed end and you must have an antinode on the open end in order to form a stationary wave. Now, looking at this system, because if I call this length L, then looking at this, I see that the first and easiest way, right, to form a stationary wave in such a system is as drawn. And what we can say from this is that the length of the pipe is exactly equal to 1/4 of a wavelength. And so this is your fundamental mode of vibration in such a system. Now let us look at how else you can form a stationary wave in something like this. Okay, so let's erase this wave that we have here initially. So remember, I must start off with a node, okay, like this. And so one thing you'll realize is that if I simply double this, if I do something like that, right, that's not going to work because then I'll have a node on both sides, and we know that's not going to produce a stationary wave. So what we need to do is to go something like this. Ooh, okay. And this is very interesting because now you see that L, the length, has to equal to 3 times of a quarter wavelength or 3/4 of a wavelength. So I skip the even or the second harmonic of this, right? And if we explore this further, let's just do one more. Okay, you'll see that this is another way to go about it. And then in this case, you will find quite expectedly that your length L, okay, L will then equal to 5 times of lambda over 4. Interesting stuff for our pipe close on one end. And so what this amounts to ultimately is that to form a stationary wave in a closed pipe system, L has to be some odd multiple of a quarter wavelength. And there you go. Okay, so remember, it is very crucial to understand that there are no even harmonics in such a system. So you'll skip all the even harmonics and must be odd, it cannot be even. Okay, and so we look at one example of sketching this. And so, for example, if n equals to 7, okay, then I will have 7 of these quarter wavelengths. So you can think of it as 1, 2, 3, 4, 5, 6, and then the final 7 one at the end over there, okay, to give you that antinode that you need.